All right, so today we're going to take a look at section 3.3, which is called the conditional. It's the one type of statement so far that we have not done a truth table for. I talked to you about three different types of compound statements. One of them was an and statement, one of them was an or statement, and those were both back in 3.2. We did truth tables for those. And the third one is a conditional. That's the if-then statement. So for starters, remember then that this is a compound statement that involves that if-then connective. That's what it is. Okay? And there's some notation that you should be aware of for this. So if you have a statement that says, if P, then Q, the symbols that we use for that is you start out with P, and the symbol that goes between them is an arrow to the Q. And I will sometimes not call this if P then Q. I will say statements that look like P implies Q. They mean the same thing, but that's another way to think about it or to say it. The next two statements on this slide aren't so much for the purpose that I care if you use them, but that if you see them, you know what they're talking about. An antecedent or a premise is the P from the statement above. And then the consequent or the conclusion is a Q. So if you see a statement written out, and there's a homework problem on my math lab or in your notes or whatever, in your book or whatever that says, what's the antecedent? You need to know what they're asking you to write down. Okay? I'm not going to tell you to tell me what an antecedent is or something like that, but if it's used in a question, you need to know what it's referring to. All right, so what we're going to do on this set of problems is we're going to rewrite things in the order with the if at the beginning and then the then part at the end. And the way that you do that on the first one is you notice there is an if in this statement, right? But it kind of looks like it's in the middle of the statement. Agreed? Well, the if does not become unconnected to the part after it. It is connected to that. So if I move the if, I have to move everything in that box. And that's what I'm going to do. I'm going to list everything in that box first. So I'm just going to rewrite the statement with the if part at the beginning. Okay? So I'm going to start out with if it is breathing. Then what? Then it must be alive. So we're just putting it into the form with the if at the beginning, the premise at the beginning, and the consequent or the conclusion, the then part at the end instead. And we use language in both ways in English, okay? But the if part is still attached to what's coming after it. So this is just a rewriting step that allows us to work with the problem a little bit more easily. Now on the second one, number 2, what do you notice? There is no if in that statement. So we're going to actually be inserting an if into the statement, but we need to be creating a statement that's equivalent to the one that's already here. So I'm going to start out with if, and what should come after that? If what? Tyler wants me to put my name in there. He. We're going to use a he because you said it. If he what? Nope. The shopaholic. If he is a shopaholic, then what? Then he has no self-control. You see, if we reword it, it's not what it's saying, because this doesn't say that there's no other people that have no self-control, right? So the people that go out and they buy, 2 double-dip ice cream cones or something like that, they don't have self-control either. Okay, so it doesn't talk about just the people who have self-control having this one particular problem. But the people who have this particular problem have no self-control is what it's saying. So this is how we would rewrite that. And you're going to have some problems that are going to have this kind of a feel to them, where you don't see an if or a then, and you need to be rewording it in a way that includes the if and the then and makes it the same statement that you started out with. Okay? All right, now we're going to do 2 problems that look a lot like the ands and the or statements we did, where we're told what the letters are, and we're told either a symbol or a sentence, and we need to turn it into the other one. So right here we've got the statement S, and S is the statement, she has a ferret for a pet. We have the statement P. P is the statement, he trains dogs. And we have the statement M, which is the statement, they raise alpacas. Doesn't it sound like fun? I think it sounds like it smells bad in their house. But regardless, we're going to use these symbols that are listed here to rewrite a statement that corresponds to them. So what word am I going to write very first? If. And why am I going to do that? Okay, the antecedent is going to be the P statement. The if's not the antecedent. How do I know that? Say that louder, Shan. The arrow. Yeah, you guys saw an arrow, right? Because you saw the arrow, that's why you know you have to write the word if. That's all. Okay, so the fact that you're writing an if has to do with the fact that there's an arrow. What comes after the if is the antecedent that Mason mentioned, though. It's the part that represents P. And what was P? He trains dogs. So the if comes to the beginning, and then he trains dogs is going to come next. What will come next? Then. Then they do not raise alpacas. This sounds like the kind of argument a child says to their parents. But if you let me get a dog, I promise, then I will do something else, right? I will never leave my clothes all over the room again. Apparently, they will never raise alpacas if they train dogs. Okay, you ready to try another one? We're going to go the other direction. So what we've got now here is we've got a statement written out, and we're going to turn it back into the symbols. So we see the word if, and we see the word then, which means we know we have an arrow. What comes before my arrow? Is it P? Tilde P, because that's the trains dogs part, right? And then what? S, because she has a ferret for a pet. What else? Or, which is the V symbol, good. M, because they raise alpacas. And the SVM is in parentheses. Okay? The stuff at the beginning is the antecedent for everything that came afterwards, the then part at the end. Okay?
Why do you put it?
Because the if part is coming before the statement that involved the or. It said if this happens, then all of these things happen afterwards.
So if you don't have the parentheses, is it three separate statements?
If you didn't have the parentheses, it would be the equivalent of saying that this piece is what was happening or the next piece happens, which is not how the statement was worded. Yeah. Okay. You knew there was a truth table coming, right? All right. This is the truth table that requires a little work because it's a little bit more complicated than the other ones to think through, okay? Once you want to memorize it, how you do it afterwards is fine, but to think through why it works the way it works is a little bit different. So what we're going to do first is we're going to start our truth table. This truth table is going to be a truth table for P implies Q. And so, of course, you guys know how that starts. You need a column for P and a column for Q and a column for all of it. P implies Q. You know what P looks like. What's the column P going to say? True, true, false, false. And you know what column Q is going to say? True, false, true, false, right. Okay, so it's the last part that we're going to use. And we're going to do this in very much the same way that we did it before when I explained the and or statements. And I think I used is a math teacher and is a mom. Is that what I used? Yes. We're going to use that same kind of an idea here, but what we're going to use is that P is a mom. And we're going to use Q is a woman. All right, so I want you to imagine with me that I've come to class today and I'm telling you we have a special guest and they're standing out in the hallway. Okay? You can't see them, so you have no idea anything about them except for what I'm telling you is true about them. Everybody with me? Okay. So if I tell you the person out in the hallway is a mom, that's the P is T, right? The P statement is a mom is true. So I tell you they're a mom. Then Q, true. Is it true that they're a woman? Yes, that would be a true statement, right? If I said the person out in the hall is a mom, you would know 100% without a doubt that they're a woman, and that would be a true statement. Okay? Again, so if I came in and I said the person out in the hall is a mom, therefore they are a woman, you'd say, well, yes, they are. That is a true statement. Now if I said to you, I've got a guest out in the hallway, and they're a mom, and they're a man, you would say, that's false. That just can't happen. That's not a true statement. Are you with me? So the second one would be false. Right? I come in, I say the person in the hall is a woman, therefore they're a man. Sorry, they're a mom, therefore a man, and you say that didn't work. Okay? Here's the part that becomes a little bit strange. Okay? So if I come in and I tell you the person out in the hallway is not a mom, and they're a woman, that's the next one, right? They're not a mom and they're a woman. Could that statement be true? Yes. It could. If I said the person out in the hallway is not a mom and they're a man, could that statement be true? Yes. So either of the last two statements could be true. So if I came in and I said this to you, you would believe, giving me the benefit of the doubt, that I was telling you the truth and say, yes, that could be true. I have no reason to believe you're lying to me, so I believe that that's true. This could be a true statement, so we will call this a true statement. So both of the last two end up being true. So anytime an implication starts out false, what happens to the result?
It's true.
It's true. Seems a little weird, right? But we're sort of giving the person who's making the statement to us the benefit of the doubt that they're not lying to us. And the statement could be true, so we're going to write down that it is true. All right? Okay. So using that idea, we're going to do truth values first. So the truth values, remember, are the one-line truth tables that we were working with before. And when we're doing our one-line truth tables, the cool kind of feature of them is that they tell us details that are helpful, right? P and R are false, and they tell us Q is true. Now this particular one does not have the letter Q in it. Number 5 doesn't have a Q in it. So I mean, you can put it in the table if you want to here, but it's not going to be used for anything. So the only letters we really need are P and R because they're really the only letters that are occurring in this particular problem. Does that make sense? You guys don't want to talk to me today. Okay. Yes, thank you. Yes. So I've got a column for P, I've got a column for R, because those are the only ones that are in my table. What else do I need a column for? I need a column for tilde R. Then what? All of it. Tilde R, arrow P. Okay. P is false. All R is false. Tilde R is true. Okay, all those details are just like what we've done before, nothing different. The last column is the part that's different. This one says I'm going to start out with tilde R, and I'm going to go backwards. In fact, let me do it this way. I'm going to go backwards to column P. So this is a statement that is starting out true. It's giving a result that's false. Is it true or false? It was false. It's actually the only false in our table. It's this column right here. If you start out true and the second statement's false, that's a false result. Okay, that's the result of me. That's the equivalent of when I said the person out in the hallway is a mom and they're a man, or therefore they're a man, and you said no, they're not. Something about that didn't work. That is a false statement. Okay, so this result here is false. Whenever I'm asked to find a truth value and I create this one-line truth table, what else do I need to do? I need to write the answer out. And what is the answer? False. So I need to write out that the truth value is false based on the table that I created. We all good? Awesome. All right, let's do another one. This one has 3 letters, doesn't it? So I've got P, Q, and R. Okay. Those lines are not working for me today. P, Q, and R. What else do I need? Tilde P. You can list that next. Sure. What's next? What's in the parentheses? So I've got Q and R. And then what? All of it. And so I'm going to do what I did on the board a little bit ago. I'm going to call this number 1 and call this number 2. And then I'm going to write 1 arrow 2. Just to shortcut the writing part. Means the same thing, right? Okay, so what do I know about P? What is it? It's false. What's Q? True. What's R? False. What's tilde P? True. All right, easy enough? Those are all pieces we've done before. And so is the next one, Q and R. So Q and R takes column Q, column R, which is a T and an F, joins it with an AND statement. So is it true or is it false?
False.
False. AND statements have to both be true to be true, and this one's not. And then I'm supposed to go from column 1, right here, to column 2, like so. So this starts out true, it ends up false. Is that statement true or false when there's an arrow, an implication? False. And then the last thing I do is truth value written out, and so I write out the word false. Okay? All right. Before we actually do an actual truth table, I want to identify a piece of language that we're going to need, and we're going to need it later on, and so it's going to come into play now. But a tautology is simply a statement that's true no matter what the truth values are. And the way you can identify if something is a tautology is by creating a truth table and having the last column be all T's. If the last column in your truth table, a whole big old truth table, you know, with 4 rows or 8 rows or whatever, has all T's in the last column, then you have a tautology. And so we're going to create a truth table next. How many different statements does this truth table have? Well, how many different components? Let me say it that way. 2 components, right? P and then Q. And then what do I have? Tilde P, I do. And then what? The stuff in parentheses, which is tilde P, arrow Q. And then all of it. So, here, let me call this number 1. And I'm going to put arrow to Q. Okay, truth table. What's in column P? True, true, false, false. If you're getting bored, that's good. It means you know what you're doing. How about Q? True, false, true, false. How about column tilde P? False, false, true, true. All right, the next one rather is an implication. It starts out with tilde P right here, and it goes backwards to column Q right here. So this is the first one where we've actually done a truth table with an implication. Now, on an implication, if an implication starts out false, the result is true. So no matter what happens as I move backwards over here, because I'm starting the statement with false statements, right? That's the statement of me telling you the person out in the hallway is not a mom, which means they could be a man or a woman and you don't know, either one could be true. So both of these results are true. So the first 2 here are true because they start out with a false statement. The third one on row 3 starts out true and goes backwards to another true statement. So that one is true. Anytime you've got 2 truths, whether it's and, or if, then, it's always true. The last one starts out true, results backwards into false, so it's false. the only one that's false. All right, now we're going to do one more line. This is going to start out with number 1 and go backwards to Q over here, like this. So this one starts out true, goes backwards to true, so that statement is true. Second line starts out true, goes backwards to false, so that statement is false. It's the only one that you get false for. Third one starts out true, goes backwards to true, so that statement's true. This one starts out false, goes backwards to false, that's true. Is it a tautology? No. So we're going to write out not a tautology. I really need you to write out yes or no whether it is or it isn't, because otherwise I don't know if you checked it or not. I mean, that's just it, right? If you don't say it's not, then I have no idea whether or not you even looked to see if it was. So tell me it's not a tautology if it's not, when you have this identify the tautologies direction bit. Okay, got another one. Who's loving the truth tables? Are we tired? Is it the weekend already?
Yes.
It is, I know. Okay, let's get through it then. What are my columns? PQR. We're always going to do them in order. Otherwise, if you're trying to check your answers in the back of anything, it's not going to work. So we're going to do them PQR in alphabetical order, no matter how they show up in the statement. All right, and then what do I need? I need a tilde Q. Any of the tildes can come next. That's helpful. Then what? Stuff in parentheses. So I've got P and tilde Q. And then I'm going to call that number 1. Okay, then what am I going to have? Everything, which is R arrow 1. All right, what's going to go in column P? 4 trues. And then 4 falses. Windows open. Man, it's cold over here. Yes?
How do you know if there are 4 or just 2 like falses?
It depends on how many statements you have. This one had 3 statements, P, Q, and R, which means it's going to start out 4 and 4. If you only had 2 statements like on our last slide, then you're only going to have 4 rows, which means you're going to have 2 trues, 2 falses.
Okay.
It has to do with the number of letters.
What if it's more than 3 or 4?
If it had more than 3 letters, I wouldn't ask you to do a truth table for it.
Okay.
Fair enough?
So, how do you figure that out, though? Like, how do you get that? I don't.
We had a formula in the last section.
Okay.
So however many component statements you have, it's 2 to that power.
Okay.
So when we had 2 component statements, we had 2 squared, which is 4 rows. And when we have 3 component statements, it's 2 cubed, which is 8 rows.
Okay.
So 8 rows is going to mean we have 4 and 4.
Okay.
Yeah. All right. So Q then is what? True, true, false, false. True, true, false, false. And R? Alternate. True, false, true, false, true, false, true, false. Nice. How about tilde Q then? So we flip around the row Q, which is false, false, true, true. False, false, true, true. All right, next one is the first one where we actually get to compare something. We're looking at row P and row tilde Q, and we're joining them with what statement? And when is an and statement true? When they are both true. So at the beginning, I have true and then false, so that's false. And the second one is also true, false, so it's false. The third one is true, true, so that's true. And the fourth one is true, true, so that's true. The last 4 all have falses in the P column, which means they're all false, because an and statement has to have both of them true, and we already strike out with P. So these are all false in the column, or in rows 5, 6, 7, and 8. All right, now let's go with column 1 and column R. and we're supposed to take R into column 1, what I've labeled column 1 anyway. So this is an arrow statement, right? This is the implication, the if-then. So this one on the first row starts out true, and it results in false. What's that one? That's false. It's the only time that they're false is when it goes true then false. The second one is false, false, which is true. The third one is true, true, which is true. The fourth one is false, true, which is true. Anytime it starts out false, it's a true statement. The fifth one is true, false, which is false. The sixth one is false, false, which is true. Good job. The seventh one is true, false, false. And the last one is false, false, which is true. Is it a tautology? No, not a tautology.
Would you write that out for every tree table or just for when it asks it?
Just for when it asks identify the tautologies. So if there's a question, if part of the directions say identify the tautologies, you're going to either say yes it is or no it isn't. Yeah. All right. The negation of P arrow Q. All right, the negation of P arrow Q takes a implication and actually turns it into an and statement. So the negation of P arrow Q, so this is kind of like when we were doing De Morgan's laws, but this isn't one of De Morgan's laws, okay? The negation, or the opposite of this, is P and tilde Q. So the first part, the premise, stays the same. I don't have any if-thens anymore. I have the word and then I negate the second part. And when we write one out, it's going to make sense that this works, okay? But this is the symbols for what you have to do to negate it. All right, so here are my two statements. I've got a statement that says, Ella reaches that note. And I don't actually have the word then, but you know it goes here, right? There's the word then. And the second statement is, she will shatter the glass. So if Ella reaches the note, she will shatter the glass. So the negation for this keeps the first part the same, which means the first thing I write down is what? Okay. Ella reaches the note. No if. No if. Okay, there's not an implication anymore. I just have an and statement now. So Ella reaches that note. What do I do next? And. Word word and. Okay, and then what do I want to do? The glass doesn't shatter, yeah? So you can write it in any way, shape, or form you'd like, but I'll write it just so that it matches exactly how this was before. And I'm going to say she will not, or does not, or whatever.
It doesn't matter on the test.
No. As long as you've written the opposite of shattering the glass, which would be not shattering the glass. Yeah. She will not shatter the glass, or the glass does not shatter, or something like that. Okay? That's exactly the opposite of what that said, right? If she does, then this is going to happen. She does, it didn't happen. Right? This is what happens at my house when I tell my son, if you take a nap, then you can have that piece of candy. And if he doesn't take the nap, he doesn't get the piece of candy. That's what we're doing when we say that to him. But if he took the nap and I didn't give him the piece of candy, this would be bad. He would know and he would be mad, right? It would be the exact opposite of what I just said. All right, there is another way to write a conditional statement as an or statement, though, as well. The way that we can write a conditional statement, P arrow Q, without the implication, is that we can write the statement as tilde P or Q. All right, so the example I have here, we're going to add a few words to make sense of it as we're working. But we can see the two statements. She doesn't, and he will. Okay? So let's do this problem as it is first, and then we'll talk about how that makes sense with it. So this statement says I need to do the opposite of the first part. So what's the opposite of she doesn't? She does. And I don't need the if anymore, right? Okay, what comes next? Or. And then what's the opposite of he will? He won't, or he will not, or whatever you want to write. He will not. Okay, so let me use a little bit more language around this so that you can see what we're doing. If she doesn't give him a bath, my children, then he will give them a bath. Okay, so let's say that. So if she doesn't give him a bath, then he will give them a bath. One way or another, children are getting bathed. Okay, so this is the equivalent statement, which now says she does give them a bath. Oh, I screwed it up, didn't I?
Okay, yeah.
I'm sorry, guys.
Then you will.
He will. That one was supposed to stay the same. I'm sorry. I'm so sorry. Please fix your notes before. Yeah, excellent job, guys. Yes, Michael, Mason, thank you so much. All right, so let's fix it, and let's say it then this way. I told you either way they're getting a bath, right? So she does give a bath, or he will give them a bath. Okay, so we keep both of the statements. Both of the statements end up being changed, but changed differently depending on whether or not the statement was being an equivalent statement or a negation.